Hello, everyone. Thanks for coming. My name is David Altamira. Welcome to the first installment of our manufacturing webinar series. So today we're going to be unlocking the secrets to revitalizing your ERP production scheduling. Our discussion today should be of interest to operating managers, whether you're in manufacturing or supply chain management, or maybe you work directly in a planning and scheduling function. It should also be of interest to business owners or executives, really anyone who has a vested interest in the business running more effectively. Just to avoid any confusion, I want to apologize in advance for the use of three-letter acronyms. For the purposes of this discussion, I'm going to be using the terms ERP, MRP, and APS somewhat interchangeably. In all cases, what I'm really referring to is whatever part of the system you look to decide what needs to be produced, when it needs to be procured, what quantities are needed, and when each item is needed. For purchased items, generally we think in terms of MRP for material resource planning, and for manufactured items, we tend to think of APS, but they both work together as parts of a larger ERP system. Also note that the improvement strategies that I'm going to be describing are probably not going to require any additional software on your part. I don't sell software. My firm is not in that business. We're really in the business of optimizing the use and function of existing ERP systems. So what we discussed today should be generally applicable to any brand of ERP system that you currently have or that you are contemplating for the future. For our agenda, the first thing I want to do is switch away from the slides, and I'm going to give you a visual demonstration of how an ERP system is, in essence, a dynamic system. I'm going to explain what that means in the context of an ERP functioning more effectively as a control system for your manufacturing sites as well as your external supply chain. I'll also be presenting you with 16 red flags that are symptomatic of ERP instabilities that may exist and you may not be completely aware of. I'll show you some real-world data for a large contract manufacturer that was suffering from fundamental ERP problems, so you can see what's going on behind the scenes. I'll also identify 9 factors that can contribute to ERP scheduling instabilities. And then finally, I'll suggest 5 resolution strategies to make your ERP scheduling significantly and fundamentally better. We'll then conclude with a special offer that's exclusive to viewers of this webinar, and I'll also be taking any questions you might have. In fact, feel free to submit your questions at any time using the chat box on the right-hand side of your screen, and I'll try to get to them at the end. So let me switch the camera and give you a visual demonstration. Okay, so here's a demonstration that I do from time to time. It's basically a bunch of springs that I've connected weights to. And the reason I do this is that mathematically, these springs and weights mathematically are very similar to what goes on from a dynamics perspective in a supply chain. In fact, there are some software developers that have used this mathematical representation to develop commercial supply chain software. And I myself have gone into companies and I've taken measurements and I've looked at how dates and scheduling behaves at different levels of the bill of material and throughout the supply chain. And I overlay that over the theoretical dynamic response of this, and they overlay just perfectly. So it's not really a metaphor, it's really a pretty good physical model for supply chain. So we can think of this as a supply chain in a small sense or in a large sense. So in a small sense, this could be a factory within your 4 walls, and you have raw materials that are coming to you from external suppliers through your purchasing function, and then those are delivered to your different work centers along the chain where they take those materials and assemble them, build sub-assemblies and final assemblies and products, and then you deliver them to a customer up here at the top. But we can also think of it in a larger sense. You could have materials coming to you from a supplier in China that then goes to a supplier in California, who then sends sub-assemblies to a different company and then to an OEM. And you could have higher in the chain, you could have distribution sites and warehouses and foreign customers. So it could be quite large. And what we talk about today is equally applicable to both of those scenarios. So the example I want to give you is, think of my hand as the hand of customer demand. And that could be sales orders from customers directly, or it could be demand forecasts that you bill to. And so that customer demand is basically activating a supply chain. And as customer demand fluctuates, the supply chain is responding. And I want you to think of this as a two-lane road. You have basically a set of orders of information that's going down. You have sales orders, and then maybe manufacturing orders and purchasing orders and warehouse orders and transfer orders. So this is one half of your control system. It's the command and control part of your control system. But then in the opposite lane, coming the opposite direction, is the supply chain responding by delivering materials and products in this direction. And it's also providing you with information in this direction that gives you information about the status of orders, like estimated completion dates, estimated delivery dates, giving you information, management information about the health of your supply chain. And so one of the things I want you to think about is what's the dynamic issues existing here. If you have volatile customer demand, maybe spikes are part of your business and unexpected orders, what can happen is that when the supply chain is activated in using that kind of very dynamic, spiky response, and it starts to jiggle, and what you'll see is some parts of the supply chain are moving up while others are moving down, and you get this out of phase motion. And the way that manifests itself is in a lot of ways, but the ones that you might recognize are having material shortages coupled with overstock in some places. And you'll also have a lot of date change activity if it's managed not in the right way. What you really want is your supply chain to be very stable. And if customer demand is stable, then the rest of your supply chain should be stable. And if it's dynamic, then there are things you can do to try and stabilize it. The problem that a lot of folks have when they're managing a manufacturing function is that they do things to stabilize the demand through inventory and things like that. But the way they manage their shop floor is they start to introduce the instabilities at lower levels. And then it transfers down through the supply chain to their suppliers. And if you look at how this chain moves, you'll see that the bottom weight, which represents your material suppliers and your procurement, that has the largest amplitude changes. So when I start to jiggle this chain, the weight at the bottom is going to be more animated than the ones up top, and that's just the nature of supply chain dynamics. So I want to introduce to you the idea that your ERP is really a control system, and we need to think of it in that way, which is not the traditional way to do it, and that there are things that we may inadvertently do. We think we're doing the right thing, but what we're doing is we're managing the system in a way that introduces a feedback loop that's negative in nature. It's a negative feedback loop, and then it leads to instabilities, and that's what we want to get out of. Okay. So let me tell you a little bit more about myself. I'm the president of Altamira Consulting. We're a small consulting firm that focuses exclusively on manufacturing and distribution businesses. All of the folks on my team are former executive managers that have been very hands-on in their businesses virtually at all levels. And we have expertise in manufacturing, supply chain, quality assurance, regulatory compliance, engineering, and also enterprise IT. ERP optimization, production scheduling and lean shop floor control are some of our specialties, and we do that for companies of all sizes that use anything from QuickBooks to SAP, and we do it in a wide variety of industries. I'm also the author of a book entitled Lean MRP, which addresses the subject of production scheduling and using production scheduling as an underpinning. We use it to establish pull-based lean flow on the manufacturing shop floor, which is not a traditional approach at all. This is really a novel innovation of ours, and we're using a computer to mediate lean flow, but we're really very directly relying on the productivity and signals as much the way that you would have Kanbans on a shop floor. We're going to be doing that on the manufacturing floor using ERP. So that's something that we're going to cover in detail in our next webinar. And here are some of the webinars that we have planned. As I say, if you're a manufacturing or a production control manager, you'll definitely want to tune in for the next webinar. And then there are a couple of others we have planned. And I also invite you to join us on LinkedIn and follow us, and we'll be announcing those webinars on LinkedIn as they come online. So now I want to get started by taking a look at 16 red flags that should serve as a signal that something's not going right in your ERP system, either from a technical standpoint or maybe procedurally by the way we use the system. The more of these red flags that you feel describe your current operation, the more concerned you should be that there could be some feedback loops that are existing in your operation. The first couple are the ones you might expect: long lead times, high WIP inventory, poor on-time performance, high overtime labor costs. These can all be driven by or exacerbated by scheduling problems. Constant expediting is definitely a big red flag. Of high indirect labor costs. If you have a scheduling staff that's constantly immersed in daily shop floor activity, then I think you need to step back and take a look at how you're using your APS system. And by the same token, if you have expediters on the shop floor, then that should give you pause as well. Difficulty replenishing finished good stocks, partially built assemblies, that's a big one. If you're in a business where you're making products that are assemblies, and you have assemblies that are waiting around for different components or sub-assemblies to arrive before they can be completed, then that highlights a need for a higher level of coordination and production control and planning and scheduling. Material shortages, perhaps coexisting side by side with overstock. That means that in some places you may have too little material, and in other places you have too much. And we can take a look at that in the context of raw materials as well as finished good inventories. A reliance on drag and drop scheduling, and also, which is similar to that, frequent rescheduling exercises. Those are both significant red flags that suggest there's a problem. And I can't stress this enough. Those are big red flags. A reliance on frozen fences. Perhaps you already recognize that there's some inherent volatility in your schedule. And so what you've done is you rely on these frozen fences in your APS system to dampen that volatility out. So my response to that is that if you have a noisy system and you use frozen fences, you're really just sampling noise at the boundary of that fence. So if you have a 2-week fence, at that 2-week boundary, you're really sampling all of the noise that's inherent in your schedule. And when you sample noise, you still end up with noise. And a similar situation is if you run MRP or APS only once a week instead of every day. If that's something you've decided to do, that's really the same kind of thing. If you have a noisy system running the system less frequently doesn't get rid of the noise. You're still sampling the noise less frequently, but you still end up with noise. If you have a cultural issue in which the schedule is not followed because it isn't believed, then that's definitely a situation in which you have to take a look at fundamentally how your planning and scheduling is conducted. An inability to reliably estimate completion dates, which is to say that your schedule is not predictive or not predictive enough. And if your schedule isn't predictive, then that could impair your ability to reliably make and adhere to customer commitments. And so all of these are red flags you should be looking for. Okay, so here I'm going to show you some real data. This was taken from a large contract manufacturer who had multiple sites, and this data is for their largest site. We took 8 days worth of data so we could take a look at the date change activity in their system, and we found that 8 to 10,000 schedule dates were changing every single day. This accounted for about 30% of all the manufacturing activity in their system. What's more is that the company had no idea that there was this level of change activity. They knew dates were changing, but they didn't realize it was this significant. And this, by the way, is not the worst example I've ever seen. It's important to understand that when you change a date, it's like throwing a pebble in a pond. The effects of that single date change will radiate in 2 dimensions. The first dimension is, you can imagine it from left to right along a timeline, because one date change can potentially affect adjacent requirements that are competing for the same capacity. But there's also a second dimension, and that's up and down along the depth of the bill of materials. So if your products have a deep bill of materials with 2 or 3 or 4 or more levels, then requirement dates at lower levels of the BOM are affected as well. And we saw that with the spring demonstration where the weight at the bottom of the chain was very animated. So the deeper your BOMs are, the more significant these issues can become. So changing one date can cause many dozens or even hundreds of other dates to change, and then you have an amplifying effect. And that's why it can be a hidden problem, is that you don't understand how much amplification is really happening. So now I want to look at the same data, but from a different point of view. This time we're looking at it in the frequency domain. So not only were dates changing every day, if you looked at the frequency of changes for a particular requirement, and you saw how often that one requirement was changing, some of them changed once a week, but some of them were changing every single day, and some were changing every 2 days or every 3 days. Now, what that means is, if you think about, in this case, the lead times in this factory range from 8 to 10 weeks. So that means that every order for every part number passing through this facility was very likely to experience at least 1 day change, and probably even more. The reason this is a problem is that when you think about on-time performance, one of the things that's the biggest lever that a manufacturing manager has is getting the operators on the floor to adhere to the schedule priority. But if the schedule is changing all the time, then we're continually aiming at a moving target and continually missing it. And that's what we want to get out of. And sometimes the outcomes can be random. We've gone into companies and have taken measurements, and we found that their ERP system was a random number generator. The frequency and amplitude of date changes were uniformly distributed, which is literally the definition of a random number generator. None of us wants a system that's controlling our supply chain to be a random number generator, but often that's what we find. So here we're focusing on adherence to schedule priorities for a single work center. So understand that with this data, we're not really interested, we're not measuring whether jobs are late or early. What we're focused on is whether manufacturing is consistently picking up the right job to work on, because executing in the best priority order is a strong determinant of whether each part will be made at the right time, and it also determines very strongly whether shipping dates will be honored on time as well. Now, there happen to be 440 blue dots on this chart, and each blue dot is representing a specific job that passed through this particular work center during the period of observation. The bottom axis is telling us the priority order that was prescribed according to the production schedule. In other words, it's telling us which job needs to be run first, which one needs to be run second, this one needs to be run 40th, which job needs to be run last, and so on. So then the question becomes, if that's what the schedule is telling us, we need to know whether or not the shop floor is adhering to this prescribed schedule priority or not. So that's what the vertical axis is telling us. It's telling us that the order in which each job was in fact executed on the shop floor. We can then see for each job what the schedule said to do versus what was actually done. If the shop floor executed in perfect priority order, then all of these blue dots would line up perfectly along this diagonal red dotted line. Now, that's kind of an idealized case, and we don't realistically expect that. But what we do want is for there to at least be a strong correlation between the direction that the schedule is providing us and how our supply chain executes accordingly. And that's what I refer to as schedule priority adherence. Now, this data is a manufacturing example, but you can imagine that the same principles apply to purchased items and the way we order from suppliers and the way that our suppliers in turn perform. The problem I'm illustrating with this real-world data is that there can be no realistic hope of a supply chain performing well if we're driving them with a set of constantly changing due dates where feedback loops may be at play. So now I'm going to outline 9 reasons why you may have feedback loops in your system. First and foremost, the single biggest reason that your ERP scheduling may be fundamentally flawed is that your scheduling philosophy may be problematic. And it could be problematic in the sense that the schedule is not set up to answer all the business questions that you would expect it to. Maybe you look at the schedule as a way to establish due dates. The problem is that those due dates don't tell you when an order will realistically be fulfilled. It just tells you when it should be fulfilled. What you're missing in that case is what we call manufacturing estimated completion dates, or ECDs, or in the case of purchased items, what we would call estimated delivery dates, or EDDs. What I'm drawing is a distinction between requirement dates and status dates. So if you're set up only to support one of those types of dates and not the other, then it's very likely that you'll always be in a position where your system may be working well from one standpoint, but it's falling short in other ways. We really want it to support all of our business needs, but if it's not, and which is quite common, then those issues may be symptomatic of a problematic scheduling philosophy. And this is where most consultants and software vendors don't set up the system in a way that ends up working very well. In fact, the fundamental purpose and role of the schedule itself is often misunderstood, which invariably leads to workarounds and usually a lot more manual intervention than is really necessary. The other contributing factor is system limitations, and sometimes your system just can't do what it needs to. And in those cases, fortunately, there's usually a way to work around those limitations. Another contributing factor is the over-management of master data, which is essentially turning too many knobs, or at least turning them in non-optimum ways. And similar to that is the over-management of the shop floor, which is a kind of a nice way of saying expediting. What's happening with expediting is that the physical reality of the shop floor is constantly being overridden relative to the virtual reality of the ERP schedule. And then you have a clashing of these incongruent realities between the shop floor and the ERP system. And then the ERP system is struggling to reconcile those differences. And then that in itself can lead to date change activity. There's also raw material shortages, engineering changes and holes, and poor quality levels. And these are similar in that they all represent unplanned events that can arise. And when they do, how does your schedule respond? Does it respond in a helpful or useful way, or does it do something that could be counterproductive? I also want to include insufficient supply chain capacity. If you're trying to squeeze 50 pounds of potatoes into a 30-pound bag, then that could be compelling you to be seeking a scheduling solution. And the problem with that is that there usually isn't a real scheduling solution. The best thing you can do when you don't have enough capacity is to prioritize work. But if you're constantly reprioritizing, then that's a problem. The last contributing factor is frequent customer-directed changes. And of course, that's an issue. And that's the way that an entire supply chain from top to bottom can get infected if the OEM at the top has a volatile ERP system themselves, and then they're basically expediting and revising orders downstream in a way that percolates through the supply chain, so that then all of the vendors' lower levels become infected. So those are some of the contributing factors. And then the question becomes, well, what are we going to do about that? So there are 5 basic resolution strategies I want to offer. The first one is to adopt a more favorable scheduling philosophy. And that doesn't cost you any money. It's just a different point of view. And you have to ask yourself, what's the purpose of a schedule? Is it to drive the supply chain, or is the purpose of the schedule, is it vice versa? Is it the supply chain that's driving the schedule? So we have to recognize that the purpose of a schedule is really twofold. You can think about it as a way to send requirements to the rest of the supply chain, but you can also think of it a way to monitor the status of open orders and estimate when they'll be completed. And this is alluding to the 2-lane road that I spoke about when I was giving you the visual demonstration with the springs and weights. Your ERP and your internal processes have to be set up in a way that supports both objectives, and unfortunately, this rarely happens. The second thing you can do is to disable negative feedback loops. And those feedback loops, as we've seen, may be more significant than you realize. What's more is that they can occur in a variety of ways. There's a control loop that exists between your ERP and your manufacturing shop floor. You have requirements going one direction and then status and feedback coming the other in the form of dates. And that's your control system for your manufacturing control system. But there's also a similar control loop that exists between you and your suppliers, and you have many suppliers, so those are multiple control loops between you and all your suppliers. Additionally, there are control loops that exist between you and your customers, and that's all your customers. There's also other feedback loops that are not shown here, but they may exist when you're over managing your master data, as we spoke about earlier. So there's lots of potential for negative feedback. And you just have to understand how all the moving parts are connected and how to properly set up the system. There's also the question, aside from your system, you need to look at the way you use it, which is your work practices. Perhaps your system is set up just fine, but the way you use it is problematic, and that brings us to policies and procedures. We want to define and carry out our work processes in a way that promotes stability. So the way that we manage our master data, our customer orders, the schedule, inventory, purchasing, shop floor, all of these facets of your operation need to be managed in a way that promotes stability and leads to better outcomes. Suggestion number 4 is to ensure a sufficiently high level of product quality. If your product quality is poor and you have lots of unplanned defects, then there's really no scheduling practice that's going to be able to overcome that. So you need a good level of quality in place, just as you will need a sufficient level of supply chain capacity. If you don't have sufficient capacity, then things just aren't going to work out, and there's not much you can do with a schedule to overcome that kind of an issue. So in closing, I hope that this discussion has led to some light bulbs going off. I hope this has been thought-provoking in some sense, and some of it has resonated with those of you who feel that you need a better way to improve your on-time performance and reduce costs, inventory lead times. So for those of you who feel that way, I want to extend an opportunity to have us do a 1-week assessment of your ERP data and practices. This is something that's exclusive only to viewers of this webinar. So this will involve an initial consultation, and we'll also analyze your system data so we can evaluate what's going on both within your ERP as well as physically in your supply chain. Our objective is going to be to look at your ERP system to see if it acts as an oscillator and whether or not it's connected to your supply chain, which is another oscillator. So our goal is to operate your ERP in a way that your requirements don't oscillate sympathetically with your supply chain, so you don't have a tail wagging the dog situation. We want to run it in a much more stable way so that we're no longer chasing moving targets. Now we're offering this 1-week assessment for $2,500, which is really an amazing bargain when you think about what the cost of ignoring some of these issues is. So feel free to contact me directly if you're interested in doing this. Here's my contact info. And I want to remind you to follow us on LinkedIn, and please stay tuned for our next webinar, which is going to talk about how to create a pull-based flow on the shop floor using ERP. And with that, I'll be happy to address any questions.